let's talk a little bit about autosomal versus sex chromosomes. So, first of all, if you take a look at all the chromosomes of a female, you'll see that they have these pairs, homologous pair for chromosome 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, all the way to 22, okay? And then they have two X chromosomes. So there's 23 pairs, okay, 23 pairs. A male, on the other hand, has 22 pairs that are homologous, like the same size, same shape, same genes. And then they have these non-homologous X and Y. The Y chromosome is what makes you into a male. Okay, it's smaller, it doesn't have as many genes, but it does have the genes that make you into a male. So what we're seeing here is males and females are the same all the way up to 22, and then XY or XX. So those are the only differences between the two sexes, okay? So these are called the sex chromosomes. Okay? And then all the other ones there, those are called the autosomes. So these ones here, chromosomes 1 to 22. And as you can see, the number 1 is the biggest, and then it goes smaller, 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 right? That's how kind of how it works. So these are chromosomes 1 to 22. They did not determine anything to do with sex, so those will be called the autosomal chromosomes. So they're the autosomes or autosomal chromosomes. Okay? Autosomal. All right, so whenever we talk about autosomal inheritance, that means the gene that we're talking about that controls a trait, like hair color, for example, even though it's not true, the gene is found on one of these chromosomes from 1 to 22. Okay, males and females are affected equally, the same, by autosomal inheritance. They have nothing to do with male, female, or sex. X-linked inheritance, on the other hand, is controlled by genes on the X chromosome. Okay, so if we, let's just make those red. It's the X chromosome. Okay, so here's an X chromosome, here's an X chromosome, and here's an X chromosome. So as you can see, females have 2 of those chromosomes, males have 1, which means females can be affected differently than males for whatever this trait is. Okay, an example would be like a calico cat. Calico cats technically are only female. There are some exceptions where genes get moved to the wrong chromosome, but calico cats have black, orange, and what is it, white? I can't remember anymore. Only the females can have that because the orange color, I believe, and the black are found in the X chromosome. So males can have 2 of the colors, not all 3. I don't know if that didn't really clear anything up. And then Y inheritance. Okay, Y inheritance is when the gene we're talking about is on the Y chromosome. So only the males are going to be affected by Y inheritance. Females are completely unaffected. So only males, that's the male sign, are affected by the Y inheritance. Okay. Now, the Y chromosome is quite small. The only genes I really know about are there's a testis determining factor, gives you testes instead of ovaries, and the SRY gene, which turns on at about the week 7 of development, and it causes you to turn into a male. Besides that, there's also, I think, a hairy ear gene. So if you're dating some guy and you look at his father and his father has hairy ears, there's a chance that that's Y. Y-linked, it's on the Y chromosome, and then your boyfriend or partner, whoever he is going to 100% have hairy ears because you always get the Y chromosome from your dad. All right, well, hopefully that clears that up just a little bit.